next lesson is going to be applying how to solve exponential logarithmic equations to the real life situations that we used last unit. So we're going to be using the same 5 equations that are up on the board, and now we can actually solve these equations. So let's take a look at number 1. Upon graduating from college, Ashley took a job with a starting salary of $40,000. If this is our initial amount, we know that this is going to be our A0. She can expect a 6% raise in pay. 6%, we know the percent tells us it's our rate. Don't forget to change this to a decimal, so this is actually 0.06. And it's a raise, which is going to be an important word. When will she be earning $60,000 a year? So let's first put this into, which equation should this be? So it's not half-life, there's no compounding interest, and it's not continuous, so it should be our original equation. So we have A of t equals A0, 1 plus or minus r to the t power. So this is our first equation. We already know that our initial amount is 40,000 and our rate is 0.06. Because it's a raise, this is going to be plus 0.06 to the t power. Now this is asking us when. So what we're looking for is, what is t? T equals question mark. That's what we're going to solve for. Will she be earning $60,000 a year? This is our y. So our y actually is going to go on this side. So now that we've set up this equation, this is now something we know how to solve. So the first thing let's do is put this together, 1 plus 0.06. So this is 60,000 equals 40,000, 1.06 to the power of t. To solve this, we got to first get the exponential by itself, so we're going to get rid of the 40,000 by dividing. Cancels out. This simplifies to 6 over 4, which is really 3 halves. This leaves us with 0.06 to the power of t. So just like what we have been doing, to get rid of this exponent, the inverse of an exponent is a log. So what we're going to do is take the log of both sides. When we do that, that enables us to bring our exponent down in front. So we have log of 3 halves equals t log of 1.06, because we took our t and brought it out in front. Now to get t by itself, this is what we're solving for, because that's what we're looking for when, which is what our time is. We just got to get rid of the log by dividing on both sides. So this leaves us with t is equal to, and now we just type this into our calculator. So we have log of 3 over 2 divided by log of 1.06 gives us an answer of 6.95. Let's round to 9. And since this is time, let's go look at our problem. Time in this problem is measured in years. So this is our answer for number 1. Okay, let's look at number 2. Number 2, living organisms can be dated by the amount of carbon-14 present at time t compared to the amount present when the organism was alive. The half-life of carbon-14 is 5,730. We already know half-life, we're going to use the equation for half-life. So A of t equals A0 1/2 to the power of t over k. So this is our equation. If the half-life is 5,730, this is our k. K is 5,730. Again, this question is asking us how long. So we're looking for what is t. We're going to solve for the t in this equation. Would it take for a 185 microgram sample? So if this is what it's starting off with, that's our initial. To decay to 24. So 24 is what it ends up being, so that's what our y value is going to be. So let's plug in our values. We know we want our y value to be 24. We have A0, which is 185, 1/2 to the power of t over 5,730. Okay, so to solve this, exactly what we did before, let's first get rid of, we got the exponent by itself, we got to get rid of the 185. So we have 24 over 185 equals 1/2 to the t over 5,730. Now that these are exponent by itself, we're now going to undo the exponent by taking the log of both terms, which lets us take our entire exponent out in front. So this is log of 24 over 185 equals, so this is now t over 5,730 times log of 1/2. So just like before, we're going to get rid of the log of 1/2 by dividing. So divide this on this side. And this is going to give us t over 5,730. Over here, I'm going to put this in my calculator. Divided by log of 1/2. So this gives me 2.9464 ... Because there is one additional step we have to do here to get t by itself. How do we get rid of this 5,730? We're going to multiply on both sides. So what you want to do here is take this, let's just press times, so we're just using this answer, times 5730, because you want to use all the decimal points here, don't round it yet. This gives us 1688, and this is asking us to round to the nearest year, so we're going to round to the nearest whole number, and this is in years. Okay, let's flip the page. Our next problem we have, a culture of bacteria is put in a petri dish and grows continuously. The culture doubles every 4 hours. So continuously, we already know it's going to be our continuous growth or decay. So we have our continuous equation. We know that the culture doubles every 4 hours, so our t is 4, that's our time. If it doubles, this is the new part for this type of problem. If it started off with a naught, this is your initial, and we know it's k, we know this is 4. If we start off with a naught and it doubles, what it ends up being is 2 times a naught, right? Because if it doubles, it just means you're multiplying your initial amount by 2. So what we're doing is we're solving for k, because we don't know what that is. So I'm going to divide by a naught, which cancels out that from either side. And it leaves me with 2 equals e to the power of k times 4, which is just 4k. Just like before, we're going to try to undo the exponent by taking the log, but because it's e, instead of log, I'm going to take the natural log of both sides. So ln of 2, what happens here, natural log and e cancel out to just give you 4k. And now we just divide by 4 on both sides to give me k. So again, put in our calculator, we have natural log of 2, close parentheses, divided by 4. So we get that our k is equal to 0.173. And this is asking us for the function. So our equation is a of t equals a naught e to the 0.173 t. Okay, so now that we solve for k, we can plug that back in there in my initial function. Now we're going to use this equation to answer part b. If the initial amount of bacteria is 100, so now we know that a naught is 100. That's your initial. How many bacteria will be there in 15 hours? This is my time. So I'm going to plug this into my equation. So I have 100 e to the power of 0.173, and my time is now 15. So this is just one that we're going to plug straight in. 100 e to the power of 0.173 times 15. Press enter. We get 1340, since it wants us to round to the whole number. And this is talking about bacteria, so we have 1340 bacteria. That's my answer for part B. Part C is asking, when will the bacteria count be 33,000 or 350,000? This is now my y value. Right, so this is what's going to go on the other side of my equation. So 350,000 equals, again we're using the same equation, so 100 e to the 0.173. But since it's asking for when, we're looking for our time. So we don't know what time is. So we're going to solve for t again. So this is the same format that we're used to. We're going to first divide by 100. This gives us 3,500 equals e to the 0.173t. Now that I have the exponent by itself, take the log of both sides. Since it's e, I'm going to take ln, natural log. So that I have natural log of 3,500. These cancel out, leaves you with 0.173t. To get t by itself, we're going to divide, and again put this into our calculator. So we have natural log of 3,500 divided by 0.173, and this leaves us with 47.171, and this is our time. And so if we look up at the rest of our problem, time is measured in hours. So don't forget your units. Okay, last problem. For problem number 4, suppose you plan to invest $2,500. So this is how much I'm starting off with, A naught, at an annual rate of 7.5. So this becomes 0.075. How much will you have in the account after 5 years? Time is 5. If the balance is compounded quarterly, which means my n is 4. So now I know it's going to be compound interest. So I'm going to be using my equation for compound interest, which is this one right here. I actually already have most of the information I need to solve this one, right? So my initial, or my principal here, is 2,500. I have 1 plus, my rate is 0.075. My n, number of times it's compounded, is 4. To the power of 4 times my time is 5. So this is just going to go straight into my calculator. And it gives us 3624.87. Since this is asking us how much money, it's in dollars, so we can round to 2 decimal points. For part B, how long will it take to have $10,000 if the balance is compounded quarterly? So this is now my y value. This is what I want to end up with. I know I started off with 2,500. My rate is still the same. It's still quarterly. The only thing I don't know is my t. So I'm still going to solve this the same way I have before. I'm going to get rid of this 2,500. 10,000 divided by 2,500 leaves me with 4. So now I have 1 plus 0.075 over 4 to the power of 4t. My next step is to take the log of both sides, and the reason why I'm doing that is so that I can then move this to the front So I have log of 4 equals 4t log of 1 plus 0.075 over 4. Again, I divide by this log, and I can just keep this inside of my log. And so when I put this into my calculator, I get log of 4 divided by log of 1 plus 0.075 divided by 4. And this is equal to, when these cancel out, I still have a 4t on this side. So this is 4t equals 74.6267 ... It keeps going. So to get t by itself, I still have to divide by 4. So I'm going to take this and divide this by 4, and I know that my time is equal to 18.657, and this is in years. Last problem here, how long will it take to have $10,000? So this is what I'm ending up with. If the 2,500 that I'm starting off with, this is new, now it's continuous. So if it's continuous, I'm using e to the power of, so this is a of t equals p e to the kt. So my rate is still the same, so it's still 0.075, and I'm still looking for my time. So same thing we just did, except for now we have E. So again, I'm going to divide by 2,500. This leaves me with 4 equals e to the 0.075t. Now for this problem, since I have e, instead of using log, I'm going to use ln so that these cancel out. I get ln of 4 equals 0.075t. One more step, divide by 0.075, and I know that my t is equal to ln of 4 divided by 0.075, which gives me 18.484 years. So slightly less time if it's continuous than if it's compounded quarterly.